welcome for another episode of Show of Your CI/CD Pipeline. I'm really fortunate that today I have Heitor with me on the show to talk about something really cool. So, hey Heitor, great to have you.
Thanks for having me. Hello, everyone.
So, before we get started with the technical details, right, where did we meet each other for the first time? Do you remember?
I think we met at reInvent last year, haven't we? I'm trying to remember exactly where at reInvent because it's a huge place and a huge event. But I'm sure I remember it from there, I'm sure.
I am 100% sure that I remember when we met first time, right? Because it was on Saturday morning before reInvent. You were sitting in a coffee, and that was the only time I looked at Twitter in that week. And someone posted, "We are sitting here in the office." It was another community builder. If you want to come over, we are sitting here. That was Tryon at that time, and I came over
Mm.
and joined you and I think Katie on your desk, and um, essentially I met my SA there for the first time, Raphael, who you were giving a talk with. So it was really a funny thing, and since then I've been looking a little bit into what you have been doing as well, right? So I'm really excited to now finally have you here on. And yeah, what are we going to talk about?
Sure. Just one quick addendum to that one for people who don't know at reInvent. There's a tradition that I do every year. Every year I go to reInvent at least, called jet lag breakfast. So people like us who are in Europe and in different time zones, we try to get together at Dennis breakfast close to the Venetian, so we can have this sort of talks and such. That's where we met. Now I remember. Thank you. Today we will talk mostly about how we do continuous integration at Lambda Power Tools project, which is a developer toolkit, like a higher level AWS SDK to help you adopt serverless best practices and give you a boost of productivity.
Yeah, that's cool. But how do I use Power Tools as a user? So how do I
Sure. So,
interact with it?
of course, yeah. So Powertools is a library. So we have that available in four languages: Python, TypeScript, Java, and .NET. And you can install it as any library that you normally would. And you can use Powertools. And every language has a different feature set, but we're working hard on the feature parity angle. But let's say you want to do distributed tracing. So you want to know any anomalies that your application has, how long it takes for a request to go from point A to point B, for instance. You would use Powertools Tracer. You essentially instantiate a tracer class, and you simply annotate your code where you want that tracer to trace, and that's it. If you want structure logging to get all your loggings as JSON, you do exactly the same. Instantiate a logger, annotate, that's it. We use a lot of annotations for a bunch of things. We can show you screenshots in some of those features, but as a whole, we do things like common best practices from tracer, generating metrics, logging, batch processing, item potency, feature flags, validation, you name it, all these things. Typically, you would do a well-architected review now with serverless web architecture review, should I say. With Power Tools, you can get roughly 54% done in 1 hour now with
Wow,
Power Tools.
wow, that
Yeah.
sounds powerful. But if I understand that right, it requires the developer of a Lambda function to incorporate Power Tools already, right? Okay.
Yes, that is correct. Yeah. One of the issues we had at well architected was typically well architected is split into there are processes your company should have that are supposed to have a level of maturity. And there are certain things you have to do that are infrastructure level, using infrastructure as code, configure your AWS service in a certain way, security wise. And eventually you get to a point where you have to change your code to adopt certain practices, security wise, performance, you name it. So PowerTools tries to tackle the last part of it, which typically would take you weeks or months to get some of these pieces done. Now you can do Power Tools mostly in less than 10 minutes or less.
Wow, that sounds very powerful as a developer. Um, let's dive a little bit on the CI/CD direction before we go into details. Let me try to suite what that means. So, as
Mhm.
we are developing an open source library in 4 different flavors, we need to have a robust CI process, and then we also need to have a robust CD process to make it available to the users at the end. So how do I, as a user, then later consume Power Tools? Do I need to bake that in as part of my Lambda function, or do you already provide layers that users can just use?
Yeah, absolutely. So before I get into the Lambda layers aspect, so Power Tools, if I were to generalize, let's pick Python as the most mature and the longest one we have, is we have as a Python library, you can just use a pip install your favorite dependency management tool.
Mhm.
You can use the AWS console to pick a Lambda layer within the region that you want. You can use CDK, Terraform, any of our infrastructure as code tool to also add as a Lambda layer that we provide you one of these. And if you don't like Lambda layers because you want a semantic version to match exactly what's being published, because Lambda layers have a automatic versioning, you can use SAR, which is Serverless Application Repository, which we pre-package for you. So essentially deploys a Lambda layer with the correct version that matches the semantic version that you want. So we make it as flexible as possible across every region that Lambda supports.
Wow, that sounds like a lot of things that we can discuss about, right? Which is why when preparing for this session, we already decided that we're going to focus on the CI part today, and then we're going to do another session around the continuous deployment pieces, because there's so much different flavors on how you need to bring Power Tools, new versions, new releases to the users, right? So that is going to be a separate session. So today we're focusing on the continuous integration part, and I think we did enough introduction. Let's jump into it, right? So how do you do that stuff? And I'm not sure, do you want to share something on your screen directly? Do you want to get started with that?
Yeah, I'll share my screen. It might be. All right. So here's Power Tools on GitHub. So we are available on the AWS-Power Tools organization on GitHub, and this is the Python one specifically. There's a ton of information here. We will only look at the CI part, and then I guess on the other video we look into this CD part. So let me just use the second tab. This is in our contributing guide to make it easier for people to understand what is the experience to contribute to Power Tools. And one of the sections when we suggest customers should use pull requests to make a contribution, be that code, be that documentation, whatnot, there's a graph which should be feeding on the screen, hopefully, that explains all of the steps or checks it goes before code gets merged. This is not the release process. This is just you trying to set up project for the first time and making any change, any contribution, a new feature, documentation, your testing, you name it, and everything that happens until we merge your pull request and additional checks we do afterwards to make sure everything is safe and we're not going to impact all of those customers using hundreds of places and several hundreds of thousands of functions. What do we do first? So we use Makefile as a way to make it accessible for most people to use the project to run some of those checks locally and such. We tried not to assume everyone will have access to a bunch of tools into a cloud development environment. They can also use their local machine and whatnot. So we offer two flavors. They can even use a Gitpod, which is a cloud development environment, or if they can just use a local one. When they use a local one, we offer one command called make dev. And what that actually does after you check out the project, of course, is we set up all of these things. We set up the virtual environment, so we try to isolate, this is the project. We don't want you to get into your other projects' dependencies. We install all of the dependencies, and we do something really interesting that took us a few years to get right, which is a pre-commit hooks for Git. This allows us to have that quick, fast feedback loop. If you make a change that will eventually get blocked in CI, you can get that straight away. And we don't have to do the checks on all the files across the code base. It only runs for files that has actually changed. For instance, a linting thing or security check or complexity check, you name it.
Short question on that one. Why did you decide to use pre-commit and not pre-push hooks?
So in this case, it's mostly that we want to make sure we give at the very earliest stage before they commit. In the past, we tried to do something like pre-push, and we had PRs which had hundreds of commits, and that ended up getting the negative feedback that, please give me that feedback earlier so I can correct, and I end up with, oh, now I have to make another commit and such.
But okay, so I'm asking that question because I'm more the like I commit 100 times per minute guy, right? And then I only push when I'm ready to push my changes, which is why I was asking that. But it makes sense, right? Because you then also need would then need to squash commits when you merge, right? If you do that approach, which is once again a little bit of a problem as well. So I understand that, and just wanted to hear your thoughts. So cool, thanks.
Yeah, yeah, of
How long
course.
does it take usually? Sorry.
Oh, this is pretty fast. That's why we use the pre-commit hooks, and we also have things like only run certain checks if a certain file extension, a certain folder, a certain piece actually changed. For instance, we have one of those checks to see if you are changing our GitHub CI automation to add anything that might be insecure. So only if those files are changed, this check will specifically run. Otherwise, it skips automatically. We use a framework called pre-commit to handle all of that stuff for us. And it also isolates things like, I don't expect people to have Golang at their machine. So they automatically go and fetch a Go binary or compile as possible, or use a Docker image from a particular GitHub action linter that we use. And that goes from linting documentation and vice versa. One quick comment that I forgot to mention here, as you mentioned, the pre-push and the squashing and everything. Powertools has contributors coming from every place and not only developers. And we have a good majority of our customers being data engineers and data scientists and non-developer roles. So these pre-commit hooks can also help them not feel that pressure of, I'm going to make my first contribution or whatnot, and people will see how I structure my commits and how many commits I make and whether that has a correct commit message or whatnot. So this takes this pressure off of them because they know if the commit doesn't succeed, it's not going to be in the quality we need.
Okay, that makes sense. Are these pre-commit hooks for all languages the same or similar, or?
Yeah, so certain languages like Java or TypeScript, they would have additional checks and different pre-commits if you like, but the framework is the same. It works for any language, and certain checks are universal. For instance, we automatically check, which is one of those pieces here, if as you're going to make a commit or before you do something, is there any particular merge conflict that we can avoid straight away? Or is there a particular JSON that's completely invalid or YAML or whatnot? So those are, we kind of try to separate into, these are project code standards, quality that's specific to a language. And these are things that are more universal. Everyone uses, in this language, Powertools. All of us use GitHub Actions, so the linting will be exactly the same. And everyone uses Terraform and CloudFormation and such.
Okay, cool.
Awesome. These are the only manual pieces that happen in everything that you're seeing here. So we suggest them to create a local branch. We make some suggestions, recommendations, but they can use any name they want. They can make the changes, features, documentations. We can also run tests locally by using make tests. And we also make it easier for you to run the entire Powertools documentation offline. So you can kind of go back and see what you need, like using make docs local or Docker if you don't want to install anything. In the checks of these commits, like I mentioned, the merge conflict, some spaces, some configuration specifics. The linting has hundreds and hundreds of coding standards for Python, at least. Luckily, we just switched to a new tool, thanks to Leandro, one of our maintainers. And all of these hundreds of checks, security-wise, coding standards, best practices for the Python industry, and etc., all of them running 1 millisecond now.
Wow.
Which is pretty interesting. And it goes back to your question on the pre-commits. All of it is super fast.
maybe we can add the link to that new tool that you introduced, and maybe also to the PR, right? To the show notes later. So if people are interested to adopt that, they can have a look at that.
Yeah, absolutely. Yeah. We went from 25 seconds to 1 millisecond now, which is pretty impressive. We also do markdown linting. One of the pieces that we learned in the documentation, we take documentation as a product. So we spend a lot of time making sure everything is crystal clear. And as part of this pre-commit checks, if you ever change a markdown file, you will go through standard industry practice rules, if your markdown is correct, if it's clear, yada, 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 but also some custom linting rules that we're working on as well. Like I mentioned, if you ever change CloudFormation, we use CFN lint to do the usual AWS standard practices. GitHub Actions, like I mentioned, this is a super key one that every open source project should have it. Or if you use GitHub Actions as your CI tool, one of the things that it took us a while to learn was, which I can show you in the note as well later, if you use a GitHub action and you say, use this GitHub action, most examples, tutorials, and documentations use a Git tag or a version at v1, at v2. This is not a good security practice because this means it's a mutable reference. Any customer, any other end holding you that particular action can change that eventually. So this linting at the pre-commit level and then later at the server CI side, we check if you are using an immutable reference to this as well. And then Terraform and any potential secrets that you might be accidentally leaking, like access keys, and because it can happen, sure.
So one question on that one. We have CloudFormation and Terraform. What the hell? That's why.
In Powertools, like I mentioned, we are focused on the application side. When it comes to infrastructure, you can use anything. So some customers use SAM, which is our documentation uses as our first recommendation. That's why the CloudFormation linting. But we also have parts in our documentation. Ideally, we should get this everywhere, but we're baby steps. We have examples on how you can use Amplify CLI and how you can use CDK, how you can use Terraform, for instance. So all of our documentation snippets and the infrastructure that we provide to you are automatically linked as well against good practices and whether we do it or not. So if you're changing documentation, I think I should even show in here. If you're changing our documentation, we have examples. So if I go to any of those examples, I have the infrastructure's code and I have the source code for that code snippets. So this linking happens to SAM, CloudFormation, Terraform, and eventually others.
Okay, so this CloudFormation and Terraform that is mentioned here is not infrastructure as code required for Powertools itself. It's rather examples for the end users.
Yes, exactly.
Okay, that's okay. That makes more sense. That's and then also if you have CDK code included, that's already covered by the normal code linking that you have up there, right?
Yeah.
Okay, cool.
Yeah, exactly.
Okay, got it. Now. Okay, gonna ask that other question when we talk about CD. So let's move on.
Okay, no problem. And when you are about to make a pull request, one of the common source of anxiety for most people contributing to open source is my change gonna fail a pull request? Am I gonna be in an endless cycle of this fail, I need to make this change? To avoid this, we try to make as much as possible. Nearly all of our automation that runs in CI, you can run locally as well. So we have something called make PR as a target, which run all these checks. So you get higher confidence that when you make a pull request, you highly likely succeed at CI as well. So we run all these tests like the actual code linting, like I mentioned before, but not just in your change across the entire code base. In case you merge something that was accidentally wrong, it can happen. The docs linting as well. We also do static typing analysis because we're using a dynamic language. We want to make sure that everything is statically annotated and it passes the right typing, the typing theory and such. We also run all the tests, not only for the change you're actually making it. We run unit tests, the functional performance in case you have some regressions there. And these are more complex ones. These are what we call baselines. Our baselines serve two purposes. One is linting can accidentally miss certain things. So we want to run some static analysis to see if a particular for loop that you're making, it's too complicated that accidentally can make it difficult to maintain, or we accidentally cause a new bug or a new security issue, for instance. So these security and complexity baselines are testing against common practices and try to understand the complexity of your code. If you have too many nested ifs, and we have a particular bar that we say, the code has to be this high quality or this quality to actually pass our baseline. And then if it fails, it shows you exactly where, which we can discuss at the pull request level.
Okay.
And everything else we just did.
These tools that we have over there, right? They are all also open source and can be used by other open source tools as well.
Yes, everything we do in Powertools is open source, so everything is fully documented as much as possible, so you can always see it.
Okay, cool. Thanks.
Okay, so now you say, okay, I'm good to go. I can make a pull request. You can use GitHub CLI, you can use the UI, whatever makes you happy. And once you make a pull request,
so just 1 second. At this stage, sure. At the end of that purple part, we finished the work on the developer side of it, right? So this is where we move over from the developer machine to GitHub, whatever, right? Where then the rest of the checks and the rest of the CI part is going to happen, correct?
Yes, that's exactly correct.
Okay, so a lot of things that happen on my local machine if I want to contribute to Powertools, right?
Yeah, and luckily, all of these things, the only thing you have to make it manually is actually, well, checking out the code, which is a necessity, and the actual changes that you actually make, your initial branch and the changes you want to make and the log test you need to write. Everything else is automated.
Okay, so there's no code whisperer integration yet where I can say implement this change for Powertools and it's just going to do it for me?
We can always ask the code whisperer team to make that process easier. If you're listening, well, here's a feature request for you.
That would be fun. Okay, so now we move over to the GitHub side of it, right? So that's the tool that you have at the moment, right?
Yes. So you are happy, you make a pull request now, and the first thing that we check is if the title of your pull request is semantic. So think feature or docs or chore or refactor and such. The reason we do this is it comes out of the usual frustration of open source when you end up having too many opinions, you have a high quality, and you accidentally make it too difficult to make a contribution. So instead of checking whether your Git commits are semantic, we check the PR title is semantic, and then we would squash that and merge so that commit that the title is actually crystal clear, and you don't have to worry about learning all the Git commit semantic messages and such, because it might be your first time contributing it to, right? So that's what we do. Another one we also do is everything that happens in Powertools has to have an issue. We are very cautious of not setting the right precedents as well, even from maintainers making the right commits, for instance. They can't, it's protected branches. And every pull request has to have a related associated issue that says, this is the problem or this is the change I would like to implement and such. So we check for that shit. Another one that it took us a while to get it right is what we call acknowledgement check. In open source, you are taking the time to understand the project and also make a contribution. And in most cases, that project will have a license well defined. So in our case, we use MIT 0, which is a tiny modification from Amazon that says no attribution required. You can distribute, you can fork, you can do anything you want. When you make a pull request, you are acknowledging that we're going to take this code after the quality and everything else goes through, and we're going to be able to distribute your code as if now part of the project. And some people accidentally remove these things, and we can have potential legal issues and licensing issues that someone could technically say, I contributed, this code is mine, I want you to take it away. In this case, we're preventing from these unpleasant situations where this could potentially happen in the future. Okay. The very code specific is you can run these things locally, but we don't expect you to run it. When you run those tests locally using make tests, we also show the code coverage. But we have a UI that we use a tool called CodeCov. It's a service as well. where we can visually show you the change that you're making impacted the code coverage by X. And this is exactly where it shows, so you can see a visual representation of it. Like I mentioned, everything can run locally, and you can also have a HTML page showing you the exact changes, where it changed or not. But we want to make it easier so you see as a comment on your pull request. The next one is rather easy. As a maintainer, you never know if this is a quick win and something can merge straight away, or if it's something that's going to take a while. So we want to measure how big is the pull request. And if it's large enough, we have automation to say, this is too big. Cognitive load would be a problem here. Could you break it up? And this helps us also to prioritize small pull requests that are making one change only versus something that we have thousands of changes and such.
Mm-hmm.
Because we use a semantic PR, we automatically know, is this a feature? Is this an enhancement? Is this a refactor, documentation, a test, and such? So we do this check as well. And this, sometimes you have contributions where you add a new dependency, development or not. We're very conscious about this. We try not to add any dependency whatsoever unless it's strictly necessary. There's a last resort. Because Lambda, we have to keep in mind packet size. To give an idea, Powertools for Python is 160K to use all these features. Then obviously you bring additional dependencies afterwards. Even layers where we compile everything is 2 megabytes, all those features. So this makes sure that if you ever bring a dependency, development or not, does it have any common security issue that we should address, what we call CVEs, common vulnerabilities. Then we do again, just in case you accidentally, maybe intentionally, skipped the commit hooks, you could do a git commit no verify. So we make sure that this didn't happen. So we run all these things again. I'll pause here for a second. This is just a pull request that happens every time there's a synchronization or change in a pull request.
And this also runs as GitHub Actions and kind of magically as pull request checks within GitHub, correct?
Yes, exactly. All of this exactly there is a GitHub action.
Are we lucky to see a pull request, a live pull request that is open right now with kind of all of those checks? Are we lucky enough to just try that and have a look?
Yeah, absolutely. So let me go into one of those things here. There's one that I'm adding now, which is failing. I couldn't get to work yet, which is another step we're going to do a CI. If we just look at this one, and then one that I'm actually adding now, which is continuous fuzzing to check for memory leaks and live. So that's passed. So the pull request I mentioned, the issue number, the semantic pieces and all those labels automatically checked. The size that I mentioned to you, whether this is a feature, if it was missing an issue, which it was when you opened, now we can remove it. So if I just remove the not merge and needs an issue, you automatically allow the PR to be merged now automatically. Actually, this one as well. Agreement, which was removed, it wasn't using our templates, now it's corrected. Okay. So if you look at all of this at the bottom, you're going to see some of those checks. So if I look for, actually, this is not ready for review, so it's not going to show up. Let me take another one here. Here, the one that's actually failing now. The dependency, let me zoom in a bit so it makes it easier. The dependency review that I just mentioned, the GitHub Actions checks, we're looking for security practices to accidentally, in case you copy and paste from the internet. The fuzzing that I'm working on right now, I'm looking at running a address, dangling pointers and stuff that you're accessing accidentally, and additional memory and bugs that can happen. The semantic PR, and there are other checks that which hasn't run in here because I haven't changed any Python one. To give an idea of the scale, if I look at my actions, we run close to 41,000 already. Wow. And we run we run 100 per day-ish. And if I look at code quality, so this one that we just did, that was just converted a few tests from functional to unit tests. You see this quality checks that I mentioned to you in every Python version. So if I take any of this, it goes from linting, static checks, tests, baselines that I mentioned to you, code cov and whatnot.
Cool. This is really amazing. This is a full-blown CI pipeline. It's really cool.
Yeah.
And you as a
Yeah.
developer directly see that within the pull request, right? Which is kind of really empowering you to take actions on it, right? Before actually pinging Hater, can you please review this PR, right? Well, Hater will not look at it until all of the checks are green at the end. So that's, I think it's really encouraging for the team members as well to work and easy to work with that as well. So that's cool.
Yeah. Yeah, exactly. Yeah. Like I said, we could go on into a bunch of these things. These are all the checks that we run, which is quite a lot.
That is kind of a lot, and it feels like there's so much work going into the CI part of the pipeline, like that this is a software project as its own, right? So given we are already at like 30 minutes of recording, which is pretty long for one of my sessions, let's have a quick look on the after merge checks. What does that mean, and what is different to the CI checks that we did for pull request? So what happens after now you pressed merge on that pull request?
Sure. First thing we do is we run end-to-end tests. One of the pieces we got from pull requests is we don't want to block the pull request to be merged quickly. If like we have I wouldn't say a written rule, like 90 seconds, all these checks runs in less than 2 minutes. So pull request is fast. So end-to-end test will take a while, like 9 minutes, maybe 10 minutes, depends. So we run this after the merge. We run.
Sorry. Stupid question too. Technically, the
Mhm.
brown part is a GitHub workflow that is executed after a pull request merge on the main branch. Is that
Yes,
correct?
we use a trunk-based development, a single branch that all the changes are merged. After this change is merged, is all these automated checks are run again.
Cool. Awesome.
So you run the end-to-end test. That's when we use CDK and CloudFormation and whatnot to deploy all these things and actually check in the real Lambda function. This will take a while. And if it fails, we receive a notification, everything gets blocked afterwards from release. We run a longer SAS, which takes roughly 30 minutes. Again, another check on security to check analysis and everything else. We do something much more complex, which will take 3 sessions on its own to check against all the open security foundation standards checks, like if someone accidentally changed something in the repo or whatnot as well, and if we made it look better or worse than what we were before, our promise to you. GitHub Actions again, we also reviewed our change logs from everything that gets merged, so you always know what's coming, what's in stage and such. We deploy the staging documentation, so you always have access to this. And our release gets automatically changed, which I can show you real quickly. We made 100 releases recently, so
Wow,
101.
cool.
So this gets automatically updated. As you can see, from every change on that one was refactored, which should be at the bottom.
And that's where the important semantic versioning comes into play again, right? Because you want to showcase what kind of changes are as part of the release.
Exactly. It's all interrelated. So yeah, this is our CI. It doesn't touch the release process, which is even longer, but this is all we do. And bear in mind, all of this again is automated, except the changes that you have to make to get into the project. And all of this checks at the pre-commits and make PR is less than 2 minutes. Most of them are in 1 millisecond.
Wow, this is cool. This is really, really, really cool. One final question for the CI part before I let you go for this one. Now, in the end-to-end tests or in the longer SAST scan, if there is a failure, what happens? Is there an automatic rollback for the commit or for the merge? Or is there an alert and Heitor gets waked up at 1 a.m. in the morning? Or what is the process to avoid that this kind of moves on?
Yeah, at the moment, we follow the typical approach of not rolling back because we don't know what other changes actually go into place, which could get side effects, so we roll forward. So if something happened, we should get an alert automatically that action failed. All of us gets. So we create another issue to see if it was this a flaky end-to-end test. It can happen. If it was something more serious that we missed, then which we also run end-to-end test can run locally as well from the machine that we touch on another day. We create an issue to investigate, and then we create a pull request associated with that fix so we can learn. And we have metrics as well, which again, I won't touch into all of this, but I want to show you to finalize this whole session. We have metrics for everything. that we see it. So we want to make sure that we have on call looking into these things, the days before the first time answer and everything as well. So yes, we have a process, but we don't automatically block all the pull requests because we learn sometimes end-to-end tasks can be flaky and such.
Yeah, that would have been my next question. Like, do you block new pull requests on main until this has been resolved? Yes or no, right? So the answer to that is no, you don't. You allow additional pull request merges, but doesn't this bring up the problem like, okay, now Heitor merged, Ran merged, Johannes merged. Who is the one to blame if the third execution of that after merge check fails? Or can you drill that down to the PR that has been merged?
Yes, so should use both. So one thing is always if accidentally broke others, it means we have a process issue that we should have got in the pre-commits and the pre-requests. That's why we keep increasing this to make sure we don't have into that. The second one is that if accidentally broke something, I don't know, I updated a dependency, we didn't see it. Other PRs will fail and we'll block them from being merged and add this automatically label, do not merge, so we know, and we can trace which change was the last one from which pull request, which GitHub action, and the on-call gets notified.
Cool. Yeah, that's awesome. That's great to know, and this is kind of a big project as well.
Yeah.
So I'm really glad that I was able to talk to you about the CI part. And now just let's go back to without sharing a screen. Then I can put you a little bit on the spot. And then we can kind of end the session with an outlook for tomorrow, or for the next session, maybe not for tomorrow. I want you to come prepared to answer 2 questions for the next session. First question is, when are we getting Go support for Powertools? And second question is, when are we getting Dart support for Powertools as well? Which is something that I've been personally thinking about a lot. Now, what can the audience expect from the next session? What are we going to look at from a CD perspective for Powertools?
Yeah, so the next session we're going to cover a little bit more on this post-merge checks. There's one end-to-end task, what it actually means, what is the experience of actually running one to give us extra safety, and the entire release process. How every release of Powertools we make, roughly it's a bit more now, but what I remember at least, 168 deployments per release. We have to think all the regions, the canary testing we have to run, the beta and the prod, and then close all the issues and notify customers and make sure it's layers, it's PyPy, is NPM and whatnot. So we're going to go through the entire release process of, we've got all these changes, we're good to go, let's make a release. What actually happens to make sure everything is always up to date, test it, and when you use the library, we make sure it works.
Awesome. That sounds really, like another cool session. A lot of details that we can all learn of. And I'm really looking forward to that. With that, let's end for today. Thank you so much for today's time. And the next session will be as entertaining as this one, I hope.
Indeed. Thanks for having me. It was really a pleasure to be here. And hope to see you next session. Indeed. Thank you.